All right. So we'll be discussing SAT Worksheet 210, which covers trigonometry on the SAT. Out of 58 problems, maybe 2 of them will be trig. It's not a huge part of the test. That said, you don't want to miss 2 problems just because. So it's really easy to go through this packet and learn exactly how trig will be tested on the SAT. In fact, there are 3 ways it will be tested, and the packet has subsections that explicitly go through each of the 3 ways. The first of the 3 is you're going to have to understand Sokatoa, and you need to understand how it sets up proportions with similar triangles and often a triangle inside a triangle. The other thing you need to be able to do is you need to be able to convert back and forth between degrees and radians. Both measure an angle, they're just different units to measure an angle. And the last one, interestingly, that's a little random, in my opinion, is the SAT loves the cofunction identity. It's a really clever identity, but it's not one of the first trig identities that comes to my mind as like the core of trig identities. But anyway, we'll learn exactly what the cofunction identity is, and we'll see past test problems and how it applies to the SAT. So with no further delay, let's talk about Sokatoa. It seems like pretty much everyone in England has learned Sokatoa for GCSE. So most people watching this video will already have a sense of what this is, but let me just explain super fast. So let's just make this a 5, 12, 13 triangle. Okay, so for any right triangle, your calculator can figure out proportions for it. So an example of this is if we wanted sine of theta, so sine from this angle, that's just going to be opposite to hypotenuse. That's why it's so. Sine is O over H. So in this case, it's just 5 over 12. Cosine is from angle theta is adjacent to hypotenuse. So that's just going to be, not over 12. Oof, catching my mistake already. 5 over 13, right? The hypotenuse is 13. The cosine would be the adjacent to the hypotenuse, so 12 over 13. And then tan would be the opposite to the adjacent from the angle, so 5 over 12. So just to understand what that is important. The beautiful thing about trigonometry is that if you were to type into your calculator inverse sine 5 over 12, it could figure out for you what theta is, what the angle is. SAT won't even require that, so you can almost ignore that I said that, but you do need to understand what sine, cosine, and tan are referring to from the perspective of an angle. Okay, so anyway, here's an example of a problem pretty similar to what you'd see on the test. It's a triangle inside a triangle. We know these are similar triangles. How do we know it? By angle, angle. They both have 90 degrees. And both the small one, I'll do it in green, DEC, and the big one, I'll do it in red, ABC. They both have angle C. So the fact that they both share that angle, they have 2 angles in common, which means that the top angle of each has to be the same. And that means that what we have here is we have 2 similar triangles. Anyway, here's what the problem says. It says tan C is 5 over 12. What is the measure of line segment BA? Very important is to always, always, always keep your eye on the prize, not to give the measurement of something other than what's being asked. So we want right here, what's in blue, BA. So how do we figure this out? Well, trig is all about proportions. So it's telling us from the perspective of angle C, the opposite, right, tan is TOA, opposite to adjacent. So it's saying the opposite of the big one is going to be 5 to 12 will be the proportion, the opposite to adjacent. Well, we know that the big one actually is 15. So the fact that we know the big one is 15, we can figure out what B to C is, line B to C. We can cross multiply, or you can just realize that the scale factor is by 3. So B to C is going to be 36. So we know B to C is going to be 36. We can do the same exact thing to figure out what e to c is. And once we have b to c, we can subtract e to c from it, and that will get us b to e, right? We know ultimately that BC, line BC minus line EC, will get us BE. Okay, so anyway, we just run it through the same thing. And if you want, you can feel free to pause the video here and finish this problem. If not, I'm just going to continue going. So we know that 5 to 12 is the proportion from angle C. And actually, real simply, it's almost kind of comical. Our opposite of C in real life is literally 5. So that means that e to c is going to be 12. So we don't even, the scale factor is 1. We don't even have to really do the proportion. So what do we have here? We have b to c is 36, e to c is 12. So when we subtract them, we're going to end up getting that b to e is 24. All that's explained below, by the way, as well. So anyway, let's look at one of these problems from the test. I've picked out one that tends to really trip students up. It's number 5. And I've seen a few ways to do this. I'll show you what I think is the most straightforward way. Give you a second to look at the problem. What it says is, it says, in the figure above, the area of triangle ABC is 2x squared. What is cosine BCP? So to know cosine of this right triangle here, I'm going to put it in yellow. So to know cosine of BCP, and C is the perspective of the angle we care about, we need to know the adjacent, I'm going to say A, to the hypotenuse, I'm just going to call it H. So that's what we need to figure out. It feels like we're miles away from having this, but we just kind of have to trust the process here. So here's what we do know. What we do know is that 1/2 base times height equals area, which in this case is 2x squared. Okay. What do we know from there? Well, we know that the height in this case is going to be x. We know the base is x plus a. And we know that we divide it by 2, and that equals 2x squared. So we'll move that 2 out of the denominator, and we'll multiply across the top, and what we get is x squared plus ax equals 4x squared. Again, I know it may feel uncomfortable at this point, but you just kind of have to trust what you're doing. So what you'll do from here is you'll subtract x squared. So if you subtract x squared, you're going to get ax equals 3x squared. You can divide out an x. So what do you get here? You end up with a equals 3x. And you may be saying, well, what good is that to me? Well, actually, it's very helpful, because trig isn't about always knowing exactly what the length of the side is. It's just about understanding the proportions. So we know that a equals 3x. So now we have 2 proportions on this right triangle here. So now if we want to, we can say, we can use Pythagorean Theorem. So x squared plus 3x squared, and make sure you put 3x in brackets, otherwise you're not going to get this, right? You're squaring the whole thing, equals h, the hypotenuse that we want to know, h squared. So what do we get here? We get x squared plus 9x squared equals h squared. So essentially, I'll move down here, we have 10x squared equals h squared. So root 10x equals h. So this side is root 10x. And it wants to know the proportion of cosine BCP, so it's 3x over 10x, root 10x. The x's cancel out, so it's 3 over root 10. So in this case, we're looking at B. Interestingly enough, if you don't feel comfortable with that algebra, what you could do, and I'll just mention this quickly, and then we'll move on to the next problem. But what you could do is, the minute you know that this is 3x, you can just plug in numbers, because it's just a proportion. So I'll make x 1, I'll make this 3. So what do we end up with? If I make x equal 1, we end up with 1 squared plus 3 squared equals h squared, right? This gets us 10 equals h squared, and we get that root 10 equals h. So what's the proportion of the adjacent to the hypotenuse? 3 over root 10. Awesome. All right. So that's the first section, and the first set of problems you'll need to know for the trig. The second is, and this is not covered in GCSE as I found, but the second thing you need to know is you need to know how to convert back and forth between degrees and radians. So don't be intimidated by radians. It's actually fairly simple. If you think about how we measure distance, we can measure distance in kilometers, miles, inches, centimeters. You pick it. We have a bunch of different units to measure distance. Well, guess what? There's another way to measure an angle other than degrees. You can measure it in radians. And there's one thing you just need to know. You need to know that 180 degrees is equivalent to pi radians. So about 3.14 radians is 180 degrees. Okay? Nothing to get tripped up on. All it means is a radian's roughly about 58 degrees. But you always have to think of it this way. 180 degrees is equivalent to 3.14 or pi radians. So how can this help us out? I'm going to skip the unit circle because that's a little more detailed, and it doesn't really, I actually found it doesn't really help for the SAT. You don't necessarily need to know it. But if you're curious, you can do some research on your own. But let's get this example problem real fast. So the example problem says, what is a radian measure of an angle that is 60 degrees? Well, we know immediately that 180 degrees is equal to pi radians. So we want to know what 60 degrees is. And I'll just put x. You can cross multiply and figure it out that way. So you can get 60 pi equals 180x, right? Divide by 180, and you get pi divided by 3 equals x. Or you can just realize the scale factor, right? This is a third of that, so this is going to be a third of pi. And if you think about it, if pi is 180 degrees, 180 divided by 3 is 60 degrees. So anyway, that's something you'll need to be able to do, convert back and forth between radians and degrees. And here's a problem for us. If you want, feel free to try this on your own. All you need to do is pause the video. But as always, I'm going to keep on talking. So we have in the xy plane above, points P, Q, R, T lie on the circle with center O right here. The degree measures of angles POQ and ROT, so POQ, so you're talking about this angle, and ROT. The one in the middle is always the angle you're actually talking about, so that angle are 30 degrees each. So each of these are 30 degrees. What is the radian measure of QOR? So here's the thing. Immediately, if you know this is 30 degrees, and you know this is 30 degrees, and you know a line is 180, you know this is going to be 120 degrees, right? And that's what it wants, QOR. So we know this to be 120 degrees. We just need to figure out what's 120 degrees in radians. Well, pi is 180 degrees. So 120 degrees, you probably have already figured this out. You could cross multiply, but 120 degrees is just going to be 2/3 of pi. So that's all there is to it, converting between radians and degrees. You just need to memorize that. You need to know pi radians is 180 degrees. And obviously, I would work through the problems in this packet if this is a new concept for you. Okay. The final thing you'll see with trigonometry on the test is something called the cofunction identity. I encourage you to have your calculator with you or to pause the video and grab it because I want you to see something right now. In your calculator, plug in sine 5. Make sure your calculator's in degrees, not radians, but plug in sine 5 and hit enter. Plug in cosine 85 and hit enter. You should get the same number. Try it for the entire table. What you'll notice is that if your sine and cosine together add up to 90 degrees, they're the same as one another. The question is, why is that? Well, I'll show you exactly why it is. I've created this 30, 60, 90 triangle, so let's use it to kind of illustrate it. So again, the idea is that if, well, all right, yeah, I might as well write the identity out. So if I have cos x, that's going to be equal to sine 90 minus x. Okay, let me show you why this is. Let's make sense of this. So let's pretend x is 30, okay? And we'll use this triangle. So if x is 30, cos x is going to be x root 3, right, adjacent ka over hypotenuse 2x. That simplifies to root 3 over 2. Okay, well, sine 90 minus x, well, if 90 minus x, 90 minus 30 is 60. So literally, if these two add up, the angle measurements of both of these add up to 90, then they're just, on a triangle, they would just be the different angles other than the 90-degree angle. That's simple. So if you think about it, for our sine 90 minus x, we're just going right across the street to the 60 right here. And if we're going opposite the hypotenuse, that's still going to be x root 3 over 2x, right? Your adjacent to hypotenuse from this angle is the same as your opposite to hypotenuse from that angle. And because these two add up to 90 degrees, if your cos and your sine angles add up to 90 degrees, they're going to be the same as one another. So what we'll do is we'll look at two problems, one that I made up and one from the test. Actually, we may look at three. We'll look at one that I made up and two from the test. First, let's do the one I made up. So if sine 7x minus 10 is equal to cosine 13x, what is the value of x in degrees? Okay, well, in order for these to be equal to one another, their degrees have to add up to 90 together. So simply 7x minus 10 plus 13x equals 90. That means that 20x equals 100, and that means that x has to be 5 degrees. Okay, so let's take a look at a few from the test. Okay, most of the time you'll get something that looks like this, and it really just requires that you understand the identity. So I'll quickly draw this triangle out just so that we can see it. So here's x. Actually, you know, let me make x up here just so things are a little bit more proportional. They say sine x is 4 to 5. So this has to be a 3, 4, 5 triangle. You can use Pythagorean theorem, or you can just remember this Pythagorean triplet 3, 4, 5. But it wants to know, what is cos 90 minus x? Well, cos 90 minus x is referring to this angle. Right? Think about it. These two together have to add up to 90 degrees, right? X plus 90 minus x. They have to add up to 90 degrees, the two of them. Well, if you think about it, the x's cancel out and you get 90 equals 90. All right. So anyway, wants to know what's cos 90 minus x. So it's actually referring to the same exact proportion, the adjacent to the hypotenuse from here. So this is just a way of testing that cofunction identity. Okay, 20 is the hardest problem I've ever seen with trig and with this cofunction identity. If you want to pause the video and give it a shot, or if you want to just do this packet and then come back to this video later, feel free to do that. But right now, we're just going to quickly cover this problem. So it says, in triangle RST above, point W not shown lies on RT. What is the value of cosine RSW minus sine WST? It's really hard to do this because we don't have W and we don't know where it belongs, so it feels very abstract. What I encourage you to do is just take a stab at it. Just make up a W. Make up a W just so that you can start to kind of see what this looks like. So if I could put W anywhere on this line and it's going to work out, and you can try it yourself. But I'm just going to put W here, and I'm going to pretend that this is 30 degrees. And I'm going to pretend that this is 60 degrees. All I know is that these two together have to add up to 90. So if we're looking at sine RSW, what are we looking at? We're looking at, or sorry, cosine RSW, we're looking at cosine 60. If we're looking at sine WST, we're looking at sine 30. Well, hopefully you remember your cofunction identity. If these add up to 90 together, they're equivalent to each other. Even if it's not the same exact triangle, cosine 60 is always cosine 60. The proportion's always the same. Sine 30 is always sine 30. The proportion never changes. By the way, cosine 60, I don't know if you have it memorized, but that's a half. Sine 30 is also a half. So we're going to get 0. And if you think about it, no matter how we split s, because s is 90 degrees, our cosine and our sine together are going to add up to 90 degrees, which means they're going to cancel one another out. Okay, anyway, I hope this video was helpful. Good luck with the worksheet. And as always, come back for more. You have videos on all other concepts SAT related. All right, good luck.